Welcome to this episode of Open-SCAD by DIY3DTech.com. In this episode, I want to take a look at a new design which we've whipped up for a Ryobi Rotary saw. I'm not sure quite what to call this guy. So basically, I'll do an overlay so you can see the unit itself, and I'll have some links down below for more information on it. Kind of long story short, what these are typically used for is trimming out in odd places and a lot of drywall work for opening up for plug openings or switch openings, etc. They also work good as a nice trimmer slash small scale router for cutting out sheet goods. So one of the things I wanted to do is create a base for it, because one of the things you'll notice in the overlay picture, the base for this is not conducive to kind of running along a straight edge or something like that. It's actually kind of wanky, and it's also a little bit dangerous, or actually a lot dangerous from this, because you can see how open it is. So I turned to Open-SCAD and whipped up a new base, and sort of the kind of idea, and again I'll do some overlays, is for the throat of it to drop into the upper base here, and then it's cinched using a 1/4 bolt in basically a wing nut here. Now I've left some openings here so you can see to line it up on whatever surface that you're using to kind of cut the sheet goods against the straight edge and all that kind of stuff, and also allow an area that can expel chips or dust or that kind of things. The one thing you do want to be careful here is to keep your fingers clear of this area, because obviously the bits inside they're spinning. Also, I would suggest holding the router itself rather than this base as you move it along, because again the throat of the router isn't that deep, or the trimmer isn't that deep, so there can be some tilting, and again this is use at your own risk. I'm just providing the code and kind of showing you how I put this together. Now it is a little unique in a couple different ways, because again I've made this parametric, so if you don't have this particular router, and there are a number of versions out there called the zip and other things like that, you could use the same base for. And if the dimensions are a little bit different, again, you can just come in here to Open-SCAD into the parameters section and change it up. The other thing which I've also done is change the, set up the base shape. So I've used a cylinder for the base shape. So if I want it to be square, I can make it square. If I want it to be triangular, I can make it triangular. I can do 1/2 dozen of another to create this base to the shape I want. And then if I want to do this in this fashion, turn it around. The other interesting thing you might notice is the code that I used to create the fillet here to add additional strength, because again when I was going through the design process, there's going to be some lateral torque. If I move the piece here correctly, there's going to be obviously some lateral torque in the forward direction or whatever direction it's being pushed, which is obviously going to stress this joint. So I wanted a little bit of strength here, and then to basically counteract that force, if you will. So what I did is decided to use a torus here, and basically just embedded the torus into the base of this object, and then just translated it up into or over top of this base disc to create the fillet. So kind of interesting stuff with regards to this. Not very hard. One of the pieces creates cinch tab. So here we go. Here's the code to create the torus for the fillet. Now this is something you might want to steal. I keep this code snippet kind of handy. I've used this a lot to create fillets, so I just kind of grab it in. And the biggest piece is with this is the translation up, and so again you can see I'm just doubling it for the router base thickness, because if I were to take it and have this, then it would disappear into the base. So this is actually allowing 50% of it to rise up above it, and then again you can kind of see how I'm controlling the creation of it through here in the convexity, and then the circle down here. So typical stuff with the extrude, but again really handy snippet of code. I find myself using it a lot as I do the cinching tab code. So again, many things that I come up with require some sort of cinching mechanism, and again you can adjust the holes back and forth. Now to create the rounded tab, I'm using the oblong code I came up with many moons ago. I just keep reusing this and reusing this, and this is sort of one of the other keys that I want to share in this video is again the reuse of code. This took me less than probably less than 30 minutes to design, and probably most of the time was spent putting the comments in and that kind of stuff. Just for readability for you guys. But to whip this up, because I've already had all the pieces or the code snippets handy, and I just pasted them in, created my variable structure, and then boom, off to the races it was. So hopefully you found this interesting. I'll have the link down below where you can get this code on the Open-SCAD site if you're interested. Also have the STLs and that out on Thingiverse if you just want to get the STLs. But I highly do recommend, kind of borrowing the code, taking a look at it, and seeing the different pieces of how it goes together. Because, again, this is another great example of how powerful Open-SCAD is again, for just a very simple amount of work of pasting together some code, you get a functional object out of it. So hopefully you found this video interesting. If you did, hey, hit the thumbs up button down below. Make sure you visit our other channel, DIY3DTech.com, where we have, you'll actually see a video on this with more detail of the object itself. Again, here we're just sort of really focusing on the code, the design concepts inside of Open-SCAD, and how to do certain things. And again, big thumbs up, hit the subscribe button with the bell, and we'll see you guys in the next video.